Okay, here we go. I'm going to give you guys a quick review of rational functions before I jump into section 3.3. Rational functions, ladies and gentlemen, are these funky ones. We looked at them in chapter 1 a little bit, but now we're going into a little more detail, okay? First of all, they're defined as a function, f of x is g of x over h of x. Your base function that you remember hopefully is 1 over x. I'll show you how that looks, okay? The key with g of x and h of x is they both have to be polynomial functions. Okay, they have to be, they can't be radicals, they can't be fractional exponents, they can't be exponential variables, they can't be absolute values. They are polynomials, and we just looked at polynomials, so that should make a little bit of sense to you, okay? The one thing with these is that they have built-in restrictions, just like radical functions. They have restrictions inherent built in. Well, these rational functions also have built-in restrictions because the denominator cannot be 0, right? So anything that makes your denominator 0 basically means that you can't do it, all right? So asymptotes are the first thing that we're going to look at. Now, an asymptote is a graph that your line approaches but never actually touches, okay? Now, hopefully you remember looking at 1 over x, and 1 over x has a vertical asymptote here at 0, right? Because that's how we find our vertical asymptote. It's found by simply looking at the restrictions. And if in 1 over x, if you have 1 over x, it says that x can't be 0. So you know what happens is that your vertical asymptote is x equals 0, all right? Now, horizontal asymptotes, we find those by picking large numbers. So if x, that's one way to find them. We'll find another, we'll look at another way soon. Now, if I chose x to be 100, that'd be 100th. 1,000 would be 1,000th. So you see that it's getting closer and closer to 0. So that means that we have a horizontal asymptote at 0. Okay, now to graph these things, what we're looking at is finding asymptotes, which is what we just did. Find the y-intercept. Well, x equals 0. Find the x-intercepts, y equals 0. Well, you'll notice that since our asymptotes are the x and y axis, we don't actually have any x and y intercepts. So the last option we have is to plot some other values. And I'm going to make a table of values here quickly for you, right? If you have x being 2, well, that's going to be 1/2, 3, 1/3, 4, 1/4, right? Now, how would you get, so let's do this. 1, it's 1, right? Sorry, I didn't even have that on there, 1 and 1. 2 1/2, 3 1/3, 4 1/4. You can see that it's going like this, but what's happening between 0 and 1? Well, let's plug some numbers in. Okay, if x was 1/2, 1 over 1/2 is 2. 1/3, it's 3. So 1/2 and a 2, and 1/3 and 3. And you have this piece here, and you'll notice if you plot some other points that you'll have this point here as well, okay? So that's essentially, oops, I lost the graph. That's essentially how we graph just 1 over x, okay? We're going to look at a couple other graphs right now too. Let's look at these ones here. 3 over x minus 2. Well, let's identify first of all, x can't be 2. So what we do is we right away put a vertical asymptote right down there. Okay? Now, if I pick a very, very large number, for example, if x was equal to 100, I'd have 3 over 98, which is pretty close to 0. So you can see that you have x equals 0, or y equals 0 as another horizontal asymptote. Okay? Now, we can have a y-intercept, but I can't have an x-intercept. So a y-intercept is where x is 0, right? X is 0. So it would be 3 over negative 2, which is negative, right? So your y-intercept, x is equal to 0, would be y is equal to 3 over negative 2. So that's negative 1.5, so you can see that it crosses right here. And then the last option is just to do a table of values, right? So a table of values would be, let's check it out. So I want to go just either side of this asymptote. So try 1 and try 3. Okay, so at 1, 1 minus 2 is negative 1. That's going to be negative 3. At 3 minus 2 is 1, so it's going to be a positive 3. So at 1, I'm at negative 3. At 3, I'm at positive 3. You can sort of see things taking shape a little bit, right? Let's see what happens at negative 1 and say 4 as well. So negative 1 minus 2 is negative 3. 3 over negative 3 is negative 1. So So at negative 1 and negative 1, there you go. At 4 minus 2 is 2, so that's 3 halves now. So at 4 and 3 halves, you get the idea. You can get a few points here. You got nowhere else to go. Here we are. Okay? Now, let's look at this next one up top there. Okay, let me fold this over here. Now, this one, hopefully you can see, if I went from 1 over x to 1 over x plus 1 plus 2, you should be able to see and compare it to your first chapter. Well, this has gone basically left 1 and up 2. And when we talk about transforming rational functions, we can think about the asymptotes as being our references. So if it's gone left 1 and up 2, the asymptotes have moved left 1 and up 2. There are your asymptotes. And now you can basically graph it the same way. You can also try by looking at your y-intercept where x is 0, so it's 1 over 1 plus 2, so at x equals 0, it's going to be 3. And you can see that that's that invariant point. You'll end up graphing it if you do some test points. It's exactly like 1 over x, except it's gone left 1 and up 2. Okay? Let's look at a couple more here. These are a little trickier, but we can still do them. Let's have a look at this one. So if I look for the bottom here, x can't be 3. So that means that my vertical asymptote right away is that x equals 3. There you go, right down the middle. Now, if I'm looking for the horizontal asymptote, right, let's try big numbers. So if x was equal to 100, I'd have 200 over negative 97, which is pretty darn close to negative 2. Boom, boom, boom. Here we go. Negative 2 is my horizontal asymptote. Now let's try some other numbers. Let's look at y-intercept first, okay? That's where x is equal to 0. So you can see that that's going to be 0, right? 0 on the top, 0, 0. So my x-intercept, all right, that's where y is equal to 0. Well, actually, you can tell that if it crosses in the origin, then your x-intercept and your y-intercept are the same. So the last thing that we can do actually here is a table of values. I want to find out what happens at 1, at 2, at 4, at 5, and we start plugging them in. So it's going to be 2 over 2, so it's actually 1. The next one is going to be 4 over 1, which is 4. The next one is going to be 8 over negative 1, which is negative 8. The next one is going to be 10 over negative 2, which is negative 5. Let's start plotting these points. Okay, so I got 1, 1. I've got 2, 4. Let's see what happens at negative 1. That's going to be negative 2 over 4. Hold on. That's going to be negative 2 over 3 minus a minus 1. So it's going to be negative 1 half. All right, so negative 1 half is about here. You can kind of get an idea of what's happening on this side. There we go. Now let's try the 4 and 5. The 4 is at negative 8. The 5 is at negative 5. And I'm sure if you plotted a few other numbers, you'd end up getting a function that looks something like that. Okay? This is the 2x over 3 minus x1. Let's look at the last one real quick. And then we'll be done with this, and you can jump into the other section here. So this is a little bit interesting because you would have a hard time graphing this if you just use test points. What I would suggest you do is factor if you can, right? And the top breaks down into x plus 3, x plus 2, and you'll notice that factors out to x, or that stays as x plus 2. Hopefully you can see that this simplifies to x plus 3. Now, if we were going to graph that, okay, that's just a linear function that's going up 3. And then it's a line that goes like this. Now, that's all good. However, you can't forget that the original function was actually this, which means that you couldn't have x at negative 2. So that means that x can't be negative 2. It's still a restriction. So what you do is you go to where x is negative 2, you find out what your y was, and you put what we call a point discontinuity in there. Okay? A little bit of a trick on this stuff, it'll pop up again. Hopefully this reminded you a little bit of rational functions. The next section will give you even more info.